Hello everyone, welcome to NPTEL class. Here is Chemistry Detective to solve your Chemistry class 12th NCERT problem 2.13 from your unit 2nd, that is solutions. Let me make you understand one time what this problem is all about, and I promise at end you will be able to understand and apply Henry's law. I give you clue that this problem is basically based on Henry's law. And situation is like this. Visualize a solution of ethane gas in water. Ethane is solute gas and water is solvent liquid. Ethane we will represent by 2, gas ethane we will represent by 2, and water liquid we will represent by 1. Now situation is like this, that when solubility of ethane gas is 6.56 into 10 raised to power minus 3 grams. I am talking solubility in terms of its mass. When dissolved mass of ethane gas in solution is 6.56 into 10 raised to power minus 3, partial pressure of ethane gas above this solution, that time is 1 bar. Now situation second is that if this solution contains 5 into 10 raised to power minus 2 grams of ethane gas, which is greater than what was in first case. In situation second, visualize that we now have dissolved 5 into 10 raised to power minus 2 grams of ethane gas. Now we have to calculate what will be the partial pressure of ethane gas in this situation. We have increased the dissolved mass of ethane gas in the solution. Now we have to answer what will happen to the partial pressure of this gas above the solution. So surely this is a problem based on Henry's law, and I will give brief idea of Henry's law. Henry's law basically governs dissolution of gas in liquids, and law states that, on basis of his observation he gave a law, and law states that at constant temperature solubility of gas in particular liquid expressed in terms of molality, or generally in terms of mole fraction, is directly proportional to the partial pressure of this gas above the solution. I will repeat. Solubility of gas, dissolved amount of gas in the solution at particular temperature, is directly proportional to partial pressure of gas above the solution. Greater the partial pressure of gas above the solution, greater will be the dissolved amount of gas. Lesser the amount of partial pressure above the solution, lesser will be the amount of dissolved gas. And exact or applied equation of Henry's law is this: partial pressure of gas above the solution is equal to product of its mole fraction in solution and Henry's constant Kh, or I may write first KH is equal to product of Henry constant KH and mole fraction of gas. I may write here gas, and this is mole fraction of gas. This is the applied equation of Henry law, which is used to solve maximum numericals based on Henry law. This is the most commonly used form of equation of Henry law equation. And here this is partial pressure of gas above the solution, over the solution. This is mole fraction of gas present inside the solution, and as per Henry both are directly related to each other. Greater the partial pressure, greater is mole fraction, or greater the mole fraction, greater is partial pressure above the solution. This is the idea I will use here. First I will calculate mole fraction, because in situation first partial pressure is given. I will calculate mole fraction. Mole fraction will be equal to ratio of number of moles of gas and total number of moles, N1 plus N2. And for calculation of number of moles of gas, I have to use its dissolved weight. I will first calculate N2, dissolved moles of, I will first calculate N2, which are dissolved moles of this gas, equal to ratio of its dissolved mass W2 and molar mass M2. Now gas is ethane. Its dissolved mass is given 6.56 into 10 to the power minus 3 gram. Its molar mass is also known to me. Molar mass of ethane, molecular mass of ethane is 30 grams. C2H6, I have to add atomic mass of 2 carbon and 6 hydrogen, it will come equal to 30 grams. Gram and gram will cancel, and number of moles of ethane gas in solution is equal to 6.56 into 10 raised to power minus 3 divided by 30, and I have evaluated this value. It comes equal to 2.18 into 10 to the power minus 4. 2.18 into 10 to the power minus 4. In scientific notation, value is this. These are number of moles of ethane gas which is solute dissolved in solution when partial pressure of gas, ethane gas above solution is 1 bar. Now I will use this value here in order to find mole fraction, and mole fraction will be equal to N2, which is 2.18 into 10 to the power minus 4 divided by N1 plus N2, which is again 2.18 into 10 to the power minus 4. Now in dilute solutions, I will go with this approximation, that is a dilute solution, and in dilute solution number of moles of solute is far less than number of moles of solvent, because solvent is in large excess. I can easily neglect this 2.18 into 10 raised to power minus 4 in comparison to N1, so I will get mole fraction, it will be equal to 2.18 into 10 to the power minus 4 divided by N1. And partial pressure, I will use now this equation. Partial pressure is equal to Kh into chi, mole fraction of gas, dissolved gas in solution. Partial pressure is given 1, Kh I don't know, and chi is equal to 2.x, or chi is 2.18 into 10 to the power minus 4 divided by N1. Or else I can calculate here from Kh, Henry's constant. This equation allows me to find the value of Henry constant, and Henry constant will be equal to N1 multiplied by N1 divided by 2.18 into 10 raised to power minus 4. This value of Henry constant I will utilize in situation second, in second solution. But in second solution, dissolved mass of ethene gas is now different. I will again calculate first number of moles, mole fraction, and mole fraction will be equal to ratio of, first I will calculate number of moles. First step will be calculation of number of moles of dissolved gas from its available dissolved mass. It will be equal to N2 will be equal to W2 divided by M2. W2 here is different. Mass dissolved this time is, dissolved mass is 5 into 10 to the power minus 2 gram. Molar mass is same because solute gas is same, 30 grams. Gram will again cancel, and now in second situation dissolved moles of this ethene gas are 1.6 into 10 to the power minus 3. Now I will calculate mole fraction in second step. Mole fraction chi 2 will be equal to N2 divided by N1 plus N2. Chi 2 will be equal to N2. Value of N2 is 1.6 into 10 to the power minus 3. N1 I don't know, number of moles of solvent water taken to form this solution, and N2 is same, 1.6 into 10 to the power minus 3. Here again I will use this idea that I will go with assumption that it is a dilute solution. Number of moles of solute are far less than solvent. I will neglect number of, in the denominator, number of moles of solute in comparison to number of moles of solvent. So chi 2 will be equal to 1.6 into 10 to the power minus 3 divided by N1. And I will use now Henry law equation. Henry law equation is partial pressure of gas is equal to product of Henry constant and its mole fraction. Partial Henry law constant I have already calculated. First Henry law constant is n ratio of N1 and 2.18 into 10 to the power minus 4. Mole fraction of gas this time around is 1.6 into 10 to the power minus 3 divided by N1. So what I am trying to do here, I am trying to eliminate N1 because N1 is common in numerator and denominator. Now problem is reduced to this mathematical calculation. I have to divide 1.6 into 10 raised power minus 3 by 2.18 into 10 raised power minus 4, and after evaluation partial pressure comes equal to this value. Also I evaluated in scientific notation, it will come equal to 7.3 bar. 7.3 bar. Now see what information this data provides us. When partial pressure above solution was 1, then that time dissolved mass was of the order of 10 raised power minus 3. And in second situation, when partial pressure of gas above solution is greater 7.3, this time around greater mass of solute gas is dissolved 10 to the power minus 2. Or in vice versa I can say, when less, in first situation when less mass of gas was dissolved in solution, partial pressure of this gas above solution was also less 1 bar, and when greater mass of gas was dissolved in solution at this temperature, partial pressure above the solution was increased to 7.3 bar. This is the answer. This is solution of this problem. One last idea is that on base of this equation, I will use this equation here. On base of this equation I can provide you one more idea, that here P is partial pressure of gas above solution, chi is mole fraction of gas but represents solubility of this gas, dissolved quantity of this gas. You see, Henry's constant and solubility of gas are inversely related. Henry's constant, because if I will take it to our LHS side, it will come in the denominator, and keeping this constant relation will be inverse. Henry constant, have in mind, Henry constant and solubility of gas are inversely related, and it has been observed that for same gas, for same solvent, Henry law constant increases with increase in temperature. Value of Henry law constant for any particular gas increases with increase in temperature. It indicates solubility of gas in solution or solubility of gas in liquid solution decreases with increase in temperature, validating the idea that dissolution of gases in liquids is in general exothermic, and in accordance to Le principle it will decrease with increase in temperature. However, it will increase upon cooling the solution. Upon cooling solution, more and more gas will get dissolved in the solution under same conditions, I mean under same pressure. Thank you. Class 12 students, follow these numerical problems because it will reciprocate you by making your concepts strong enough that you will be able to apply same concepts in many more problems you will face in future. So follow these problems, listen properly, listen complete video. I know online allows us to focus only for small time, for only few seconds or only for few minutes, depending on how much is your interest, how much keen, how much driven are you as students. But if you will watch video completely, you will be able to add ideas in your mind which will help you in future. Be blessed, take care of yourself. Tomorrow, see you day after tomorrow, because tomorrow is, see you on Tuesday, because tomorrow is Sunday and Monday is reserved for class 11 students. So see you positively on Tuesday. Watch and listen to NPTEL classes to build your ideas in chemistry for problem solving in your forthcoming NEET and JEE exams. That is it. Take care.